Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session we will see the high power switching area, that is this IPM, the high power stage, that is IGBT stage, this connector. In this IPM there are 6 IGBTs that are connected with positive and negative rail. Pair of IGBT is connected between positive to negative, and common point, center point, is connected to compressor windings. The end product signal, that is called UVW. We discussed this board in different parts. In part 1 we discussed its EMI circuit that applies power to this low power section and high power section. Video number 972A, I discussed how we can find circuit diagram, and if there is no circuit diagram, what we can do. Video number 972B, we discussed what are the safety parameters, what are the safety checkpoints before working on this board. 972C, how we can repair power supply section, SMPS section. In 972D we discussed standby power section. When this power supply is turned on, then it receives standby on command from this optocoupler and it turns on these regulators. It provides 15 volt and 5 volt. 5 volt for this microprocessor, 15 volt for this IC, for this IC and IPM section. 972D we discussed inrush protection circuit, soft starter circuit. 972F we discussed microcontroller section, how it communicates with other things. And in last video 972G we discussed ACS710T current sense IC. When we apply voltage here, these are processed through inrush current protection circuit and soft starter circuit. Then AC voltage will reach here at these two center pins, positive and negative. Both voltage will pass to this inductor. After inductor, these voltage will reach here. Then through rectifiers, this voltage will reach here. These two IGBTs will drive to reactors. We will discuss this stage in upcoming session. If we see logically, we must do this before this, but no problem. We will discuss it later. Positive voltage are reached here, ground here. If we check here, positive voltage are reached here at this point. And then negative voltage through these shunt resistors, these are reaching here, this pin and this pin. 1, 2, 3, these 3 are output points, UVW. These are coming out from this connector. So these 3 wires will reach to compressor. Let's see it in detail. How microprocessor will provide commands. In IPM section, it is intelligent power module. It contains drive section, that is low power drive, low signal drive. 6 drive signals will reach here. Then it needs power supply. Power supply 15 volts will come from this capacitor. 15 volt power supply, 6 signal lines, high voltage that are rectified high power voltage, and ground from the high voltage capacitor. This 15 volt for this low side section. High voltage will reach to IGBTs. Gate of each IGBT is connected to a separate driver section that is part of this IC, this IPM. Each signal, high side and low side. This is low side IGBT, this is high side IGBT. Two commands for these two IGBTs, two for this, two for this. U high, U low, V high, V low, W high, W low. These 6 signals are provided through microcontroller. How these signals will reach here and how it will switch. If we see phase sequence, we can say this is U, V, W. With this phase sequence, this IPM, this microcontroller will switch. This is phase A. When phase A or U is at 0 degree, it is starting from here, V will at negative side and W will high side. This is our first condition. And at this point, basically it is a timed signal. After this time, when U is high, W will turn off. Now this high side, U high, that means Q1. In this portion, this IGBT will switch. For V, we can say this is U, V, W. Now this is high, low, high, low, high, low. U high, U low, V high, V low, W high, W low. When we need this signal, that means U high, this IGBT will switch. When it will switch, now let's see logically what will happen. Positive voltage from this capacitor will pass to this winding. This is 3-phase winding of this compressor. Now positive voltage are reached here. It need now negative voltage to pass the current, to flow the current. If we check here, at this point, U high, this transistor is on, V low, that means this will turn on now. Low side current will pass this side, and at that time W high, that means this IGBT will also turn on. So now we can see the current flow. From this side, V will low, the other two windings, these ends will positive, so current flow will in this direction. One current flow from positive here, from this IGBT, from this winding here. So return path from this winding. This is our first condition until here. After this time, this W high, this IGBT will turn off. Now this IGBT will turn on. This is timing sequence number 2. Now this is on. This is already on. UH is already on, so this current will remain same. VL is already on. This is V. Sorry. But now WL, this IGBT will turn on. Now the magnetic field will change. Before this, if the resultant magnetic field was here, now the resultant magnetic field will change. It's example. Before this, current was flowing in this side from here to here, but now current will divide in this winding and this winding. This is our sequence number 2. Until here. Sorry, this line, it must be here. Now if we check this sequence, now this IGBT will switch. V low side, this will turn off. V low, UVW, this low will turn off. Now this IGBT will switch. UH is on. Now VH, this IGBT will turn on. Before this, before last two sequences, this winding was low side, but now this IGBT changed. And if we see now, in last sequence this IGBT was turned on, now it will remain on. Now we can see current flow from this IGBT, this winding, and return path now from this winding. Now the magnetic field will change. Before this here, now here, now here. Resultant magnetic field will change, and the voltage which are coming to this power capacitor DC rail, these will be switched by time to time in different windings, so that each winding will change its magnetic field step by step. This is our step number 3. Now at this stage, UH, this IGBT, UH will turn off and this IGBT will turn on. Now this IGBT will turn on. Now VH is on. UV, and this time W low side is on. This. Now we can see the current flow. Before this end was positive, this end was positive, and return path was from this winding. But now the condition changed. Now this end is receiving positive voltage, V is now positive, the other two windings are negative. This and this. So these IGBTs will receive command with these sequences. Now the next stage here, this one. Here WL, UVW, WL will turn off and this will turn on. If we check, this is on now. UL is on, UL is on, which we discussed here. Now VH is on, that is this one. It is already on in last sequence. And now WH will shift. Before this was on, now this IGBT will turn on. Now we can compare the current flow in the compressor winding. In last step, positive voltage was reaching at this winding and these two windings were receiving negative voltage, capacitor negative side. But here now in this sequence, this IGBT and this IGBT will receive positive voltage and this one will provide negative voltage. So UVW will change all the time. The resultant magnetic field of three-phase winding will change step by step. If before this resultant magnetic field was here, then here, then here, then here, so it will keep rotating the rotor. So it will cause to rotate the rotor all the time. Now this condition. Then next step, that is this step. Here V high was on, UVW, 3, 4, 5. This is condition number 6. V high was on, now it will turn off, this will turn on. This was on, now it will turn off and this will turn on now. So negative side from here will reach to this winding. From here, now this is turned on and this one is already on. U low is already on. Now this compressor needs positive voltage. This is already positive. Now in 6 steps, this phase rotation will reach back to the same position when phase A was starting at 0. Now this will start again. The same sequence when it will reach here. These 6 combinations will cause to change the voltage time to time. Now if we compare the timing diagram with the IGBT switching, in first condition, U high is on, U high side IGBT is on. Positive voltage will switch at this point. V low side IGBT is on here. W high side IGBT is on. We can say I have two windings which are connected to positive voltage, and one winding is providing return path. How? This winding V, it is providing return path, and this winding is receiving positive voltage. So magnetic field direction, the resultant magnetic field, because it is core of a motor, its magnetic index will come here because it is three-phase winding. Its magnetic angle will become in one direction. Why? The current is flowing in this way. This is our first condition. Now the condition will change to second condition. When W high IGBT, this one will turn off and this will turn on. See, before this positive voltage were reaching here. Now in next step, these positive voltage will disconnected and this IGBT will connect negative side of the capacitor. Now it is turned on, it is turned off. Now positive voltage are reaching to one winding, the second two windings, negative, negative, positive. Now the current flow differ. When the current flow will differ, will change, magnetic field will change automatically. So the rotor will be forced to move to the next condition, next position. So rotor will rotate. This is condition number 2. In condition number 3, here V high, before this IGBT was on, but now this will turn off, this will turn on. Now this is turned off, this is turned on. It is already on, so these two windings will change their magnetic field due to change of voltage. Now we can see in this condition these two windings were receiving positive voltage and this was providing return path. Here one winding is receiving positive voltage, two windings are providing return path, and here the other two windings, this one and this one, will receive positive voltage, this will provide return path. Before this, return path was from here. In next step, return path from here and here, but now the return path disconnected from here and connected to this winding, and now this winding is positive voltage. Now if we compare this state, positive voltage is here and these two windings are now providing return path. Why? This IGBT is now turned on. We are in this region now. High side is off, low side is on. This one. In this condition, two windings are providing return path, but now return path from this winding, U winding, V and W will provide positive voltage because these two IGBTs now are on. Here this IGBT was on, but now this IGBT is turned off and this is now powered on. So these sequence signals, timing signals, these are coming from microcontroller. So in the software, in the source code of the microcontroller, these timing signals are defined and their time is variable based on our required RPM of the compressor. If you see this one, This is positive, and this is return line. Now this positive and these two are return line, and then after this stage it will return back to this point. This positive, this return in again zero state, that is here, this will return back to this condition. So all these 6 conditions will repeat every time. I will attach the link of this timing signals IGBT combination in the video description. You can download over there. What will happen if any one signal is missing? For example, one line is missing. This IGBT is not turning on due to any reason. If the gate driver is bad, if gate drive signal is not reaching from microcontroller, if the IGBT is bad, what will happen now? It will not provide positive voltage. These two IGBTs are good. These two signals are good. This IGBT is turning on, this turning on. It will do nothing. Why? Because when it is turned on, it provided return path, but to complete this circuit we need positive voltage. If this IGBT, its driver, its drive signal, anything is wrong, it will not rotate the compressor. There will IPM fault. If this IGBT is short circuited or its driver is permanently turned on, when it is on, it is providing positive voltage, and in this sequence, when this IGBT will turn on and it is short circuited, it is already providing positive voltage at this point. When this IGBT will turn on, what will happen? This negative voltage will reach directly to positive rail. Might be it will damage, or due to overcurrent and a good feedback system, good protection system, when overcurrent will be drawn here is a shunt resistance in the board. That is here. Heavy current will flow, this pulse will reach here and this pulse will reach here, and it will provide inverter current error, that there is high current. Why this high current? This IGBT was short circuited, damaged, its body diode short circuited, or might be its gate is permanently on, it is not discharged, it is turned on. When it is turned on, positive voltage are switched here. Any one IGBT, high side or low side, or might be its bootstrap circuit is bad. Any possible reason. If one IGBT is on and it is not turned off, or it is damaged and it is providing permanently positive voltage, when the second side IGBT will turn on, it will make a short link in the DC rail, which will cause to produce IPM fault. Same way, if this IGBT is not turning on, these two are good. Compressor will not receive positive voltage, compressor will not rotate. It will create fault, IPM fault. Same in this condition. If one line is on, second IGBT is on. If it is not on, it will not work. There is a resistor. That is very common fault in these boards. From this output pin, there is a series resistor that is coming to IPM. Signal will pass from that resistor. Now if we see input signal, we have this resistor, 100 ohm resistor. This is current limit resistor for input protection. If this resistor is damaged, that phase signal will not reach to the IPM. This is one resistor, 2, 3, 4, 5 and 6. Out of these 6 resistors, if any resistor is damaged, that is most common fault in these boards. This drive signal will not reach to IPM. IPM will fail to switch that signal, which we discussed here. If I say we have 6 resistors here, I am bypassing the driver section. I am just only giving example. 100 ohm resistor, and here we have 10k resistor. This 100 ohm resistor, if it is damaged, this signal is coming from MCU, microcontroller. If this resistor is bad, this IGBT will not switch. This is most common failure. And sometimes IPM is bad. Sometimes these bootstrap capacitors, I will discuss it separately, and we will discuss IPM in detail in separate subject, because if we discuss everything in detail, this video will become very long. So signal coming from here, reaching here to these resistors, then passing to driver section, drive side, low side here. After that, this will switch, and IPM drive section will ensure its safety all the time. I hope this video is informative for you. If it is good, hit the like button. If you have any question, please write in the comments. If you think this video is valuable, you can share with your friends. Might be it will helpful for someone. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.